Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 8.4, and we're getting really close to the end, guys, so please keep working hard, keep doing all the little things each day. I promise you it feels a lot better when you finish a class successfully after working hard versus the opposite. So, quadratic roots. What is a root? Well, a root is, I think about roots being under the ground. Okay, we're doing some association. But in math, roots are the points at which the parabola intersects the x-axis. Okay, so it's like the point where the tree enters into the ground, okay, right there on the ground level. And they're also called zeros, solutions, and x-intercepts. The last one, I think, is the most literal, and it literally means a root is where a graph crosses the x-axis. This can be in quadratics, this can be in linear equations, this can be in cubic, absolute values. Any of the equation types can have roots, and it's where the graph crosses the x-axis. So if we have a quadratic, remember, quadratics are shaped like a U, okay? So if it's got two solutions, that means that it intersects the x-axis in two places. If it's got one solution, that means the vertex is on the x-axis. And if it's got no solutions, that means it's just floating out here in one of the quadrants. Never crosses the x-axis, okay? All right, so we've got some equations here, and I'm going to calculate the axis of symmetry, and then I'm going to use my calculator to find all the x and y values for the table, and then we're going to graph them and look to see where the graph crosses the x-axis. So we're going to start out with number 1 by using remember the axis of symmetry formula is negative b divided by 2a. Okay, this is the axis of symmetry formula. So x equals, negative b would be negative 4 divided by 2 times 1. Since a is nothing, it's 1. Negative 4 divided by 2 is negative 2. So that is going to be the x value in the center. And then I'd go here, these tables have 3 to the left and 3 to the right. So this would be negative 3, negative 4, negative 5. This would be negative 1, 0, 1. And I'm going to go ahead and look at my calculator. I'm going to put this equation into my y equals, and then I'm going to hit second table and complete filling out these y values. Negative 5, 0, negative 4, negative 5, negative 8, negative 9. And then remember, it reflects over the vertex. So this will be negative 8, negative 5, 0. And so let's go ahead and graph it. Negative 2, negative 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, negative 2, negative 9. That's right there. And negative 3, negative 8. Negative 1, negative 8. 0, negative 5. That's halfway. And then 1, 0. And negative 5, 0. And so here's my graph. Okay, it opens up because A was positive. And where does it cross the x-axis? Well, it crosses at 1 and negative 5. So x equals, we're going to list them from least to greatest in set notation. Okay. Number 2, x equals axis of symmetry first. Negative b, so this is going to be positive 2 divided by 2 times 1, which is 1. And then 3 to the left is going to be 0, -1, -2. 3 to the right, 2, 3, 4. Put this equation into your calculator. Look at the table. The y values are 9, 4, 1, 0, 1, 4, 9. All right, so the vertex is at 1, 0, so right there. 2, 1 is my next point. 0, 1. -1, 4. And then we have 3, 4. And then 4, 9. And -2, 9. Okay, connect the dots. You can see that this graph, well, first of all, it opens up. A is positive, so it opens up. And it only touches the x-axis in one spot because the vertex is on the x-axis. And so this is only going to have one root, and that is going to be at 1. The root is the x value, not the y. The y is 0. Okay, number 3. X equals -b, so this will be -2 divided by 2 times -1, because a is -1. That's -2 divided by -2, which is +1. Okay. 3 to the left would be 0, -1, -2. 3 to the right on the number line would be 2, 3, 4. And then let's go to our table in our calculator. Let's put this equation into our y equals. Look at the table. Okay, the values are -11, -6, -3, -2, and then they reflect. -3, -6, -11. 1, -2 is right here. And I'm going to ask you, is this graph going to open up or down? Pause, think about it. Hopefully you remembered that a was -1, and if a is -1, the graph opens down, okay? 0, -3, 2, -3, 3, -6, and then -1, -6. Okay. The other points are off the graph, so I'm just going to go ahead and put these on there. And this graph opens down, and it doesn't cross the x-axis, so there are no roots, no solutions. Okay. Next page, a couple more problems, then we're going to talk about the discriminant. X equals -b. If 10's already negative, then it's going to be positive when it goes in, divided by 2 times 1. It's 5. 3 to the left are 4, 3, 2. 3 to the right are 6, 7, 8. Now put this equation in your calculator and look at your table. If you do that, give you a second, you should find the values 0, 5, 0, -5, -8, -9, and then they reflect -8, -5, 0. All right, let's go ahead and graph it. 5, -9. These boxes are really small and hard to see sometimes. 5, -9. 6, -8. 7, -5. Okay. And then 8, 0. And 2, 0. Okay, connect the dots. Okay. All right, so the places where this graph crosses the x-axis, there's 2 places. X equals, set notation, funny looking parentheses bracket, 2, 8. List them from least to greatest. Number 5, x equals -b. b is 0. If b is 0, it's 0. All right, 3 to the left, -1, -2, -3. 3 to the right, 1, 2, 3. Put this equation into your y equals. Look at the graph, the table. second table, and get the values for y, 0, 5, 8, 9, 8, 5, 0. Okay. 0, 9, it's up here. Negative 1, 8, right there. 1, 8. 2, 5, 2, 5, 4, 5. Negative 2, 5, just a mirror image. Negative 3, 0, negative 1, 2, 3, and then 1, 2, 3, 0. Okay. You should know that this graph was going to open down because A was negative, and then it crosses the x-axis in two places. Those are the roots. X equals negative 3, 3. Number 6, x equals negative b divided by 2a. So this is x equals negative 6 divided by 2 times negative 3. Negative 6 divided by negative 6 is 1. Okay. 3 to the left and 3 to the right, that's going to be 0, negative 1, negative 2, and then 2, 3, 4. Put this equation into your calculator and look at the y values associated with these x values. It's going to be negative 24, negative 9, 0, 3, 0, negative 9, negative 24. We'll go ahead and graph it. So 1, 3, 1, 2, 3, 2, 0, 0, 0. Okay. And really that's all we need, because we need to see where the graph crosses the x-axis, and we have found it. So the solutions, or the quadratic roots for this equation, are at 0 and 2. Okay. All right, moving on. Let's talk about the discriminant. So the discriminant is used to determine the number of quadratic roots, or the number of solutions, as we say. You can use them interchangeably. Used to determine the number of solutions. And remember, solutions are also roots, x-intercepts. Am I forgetting one? Zeros. All of these words mean the same thing. Okay. The formula for the discriminant is b squared minus 4ac. And it's referring to quadratics in the form ax squared plus bx plus c, where a, b, and c are available. Okay? And if you have a quadratic equation where one of those is not available, remember, you use 0. So if you calculate this, and d is greater than 0, then there are 2 solutions. If d is equal to 0, there's 1 solution. And if d is less than 0, there are no solutions. So what does that mean? If d is greater than 0, the graph crosses the x-axis in 2 places. If d is equal to 0, then the graph crosses the x-axis in 1 place. The vertex is on the axis. If d is less than 0, then there are no solutions. The graph just never crosses the x-axis. So we're going to use this formula on these equations below to calculate the discriminant and see how many solutions there are. All right, number 7. Number 7, a is 1, b is 5, and c is 4. And you don't have to write that out, but I'm just trying to get you to understand where those numbers are coming from. A is 1, b is 5, c is 4. So b squared, so 5 squared, actually let me move that up. I want to make sure I leave myself plenty of space, minus 4 times 1 times 4. That's 25 minus 16. That equals 9. 9 is greater than 0, so this has 2 solutions. All right. Negative 3 squared minus 4 times 1 times 10. Negative 3 squared is positive 9. 4 times 1 times 10 is 40. 9 minus 40 is negative 31. No solutions. 10 squared minus 4 times 1 times 25. That's 100 minus 4 times 1. I'm sorry. That's 100 minus 100. And that equals 0, which means there's exactly one solution. Number 10, negative 4 squared minus 4 times 2 times negative 3. Negative 4 squared is positive 16. Negative 4 times 2 is negative 8 times negative 3 is positive 24. So 16 plus 24 equals 40, and it is greater than 0, so there are two solutions. Number 11, negative 12 squared minus 4 times 9. Negative 12 squared is positive 144. Negative 4 times 4 is 16. 16 times 9, 9 times 10 is 90. 9 times 6 is 54. That's going to be minus 144. This is going to equal 0, and that means there's exactly one solution to this quadratic. All right, number 12. 5 squared minus 4 times negative 3 times negative 8. 5 squared is 25. 4 times negative 3 is, so negative and a negative is a positive 12. And then positive 12 times negative 8 is negative 96. 25 minus 96 is negative 71. And that means there are no solutions to this quadratic equation. The graph never crosses the x-axis. I hope you enjoyed this episode of Algebra 1. I'm your teacher. This is the way.